Hello all. Today in this video lecture we will see Newton's law of gravitation. So first see gravity. Gravity is nothing but the force of attraction between two masses. See here, this apple has also mass and this earth has also mass. So what is happening here? Force of gravitation is happening due to earth. See, this earth is pulling this apple. Earth is pulling this apple through force of gravitation. But not only earth is pulling this apple. See, remember, this earth apple is also pulling this earth. This is force of attraction between two masses. So they were attracted each other, and this is force of gravity. And see, not only earth and apple were attracted to each other. See, you and table also attracted to each other, because see, you has also mass and table has also mass, and gravity is nothing but the force of attraction between two masses. You and apple also will attract to each other because both have masses. So mass is important concept here in force of gravity. So any two mass attracted to each other. But why we only feel attraction to earth, and why don't we feel attraction between you and table, us and table? So see here, let us consider that this earth has mass small m1 and apple has mass small m2, and remember that if this masses, if this m1 m2 increases, then fg is force of gravity will also increase. So, and one more concept is, this is centroid of apple and this is centroid of earth, let us consider, and distance between both of them is r. So if this r reduces, then force of gravity increase, and if this r increase, then force of gravity will reduce. See, there are a lot long stars and all, they are too far away from earth, so between earth and stars force of gravity is little bit as compared to nearer objects. So relation formula is Fg force of gravity is equal to capital G gravitational constant, m1 small m1 mass of earth, m2 mass of apple, divided by r square, square of earth. Remember, r G is nothing but a gravitational constant, m1 is mass of earth, m2 is mass of apple, and r is centroidal distance between apple and this earth, between both of these masses. So see here, if this r will double, this r will double, then what will happen? See, put here in this formula, in fg formula, put 2r, right? m1 m2 upon 2r and square. So that 2r square, that means 4r square. Here 4r square will come. So see, if these are double, then force of gravity will not double. It will not reduce double by double, will not reduce by double, it will reduce by 1/4, because see this portion here 1/4 come. So if you increase this r double, then your force of gravity will reduce by 1/4. So make graph. Here it is Fg. Fg, that means force of gravity, and here r, that means distances between, centroidal distances between any two objects, between apple and earth, like that. So if my first r, that means we can write here distance, because r will come first, distance centroid between masses. here R will come. So if R, then that means Fg is 1 by 4th. 1 by 4th. 1 by 4th, that means 1 by 4th of G m1 m2 upon R square, like that. If this R will 2R, sorry, if this only R, that means only R, that means it is, what will happen, only R, that means only Fg, right here only Fg. See R, that means Fg, R. If we put 2R here, then it will be 1 by 4th of Fg. Fg by 4. And if this will be 3R, then if you put 3R here, then it will be 1 by 9th. Either we can write directly here 1 by 4th. Here Fg will come, but here 1 by 4th, and here 1 by 9th. So what will happen here? Graph, C graph, like this. This is nothing but the inverse square law. So if your distance between two masses, centroidal distance between two masses will increase, then force of gravity will increase more. That is, then this G, we will discuss about this G. This G is nothing but the universal constant. And this universal constant C, if I write G as Fg R square upon m1 m2, then unit of Fg is Newton, R is meter square, and m1 m2, that means kg square. So unit is Newton meter square per kg square, and value is 6.67 into 10 raised to minus 11. And remember that mass of the earth, this is earth, and what is mass of earth? Mass of earth is 6 into 10 raised to 4, 24 kg. Mass of earth is 6 into 10 raised to 24 kg. And one more thing is, radius of earth is, let us notify as capital R, is 6000, approximately 6400, and that unit is, so wait for unit, 6400. What is unit? No, it is not meter, it is kilometer. Okay, so see, if your object is very near to your earth, here, like that, here drawings is not as per scale, but consider that this stone is very near to that earth, and distance between, centroidal distance between this earth and this stone is, let us consider it as capital R. Let us consider it as some R, small r, okay, small r1. But see, this object is very small, very small. This drawing is not as per scale, that's why it is seen you large, but it is very small. Then what will happen? The centroidal distance between this stone and this earth is equal to radius of earth, because this is a radius of earth. And here, for in this case, assume that mass of earth is capital M, and this mass of stone is small m. Then what will change to that formula, this Fg is equal to this gravitational g will come, it is constant, and this mass of earth m upon small mass of stone upon radius central distance between stone and earth is capital R and square. So see, we know that radius of earth, I told you, 6,400 kilometer. We know that mass of earth also, we saw that mass of earth is 6 into 10 raised to 24 kg, and we saw that gravitational constant is 6.67 into 10 raised to minus 11 newton meter square plus kg square. So if you if you put all those values, this kilometer put in meter only. If you put all these values, then what will happen? This value comes 9.81 into meter, and this 9.81 is nothing but the g, small g, acceleration due to gravity. So if you pull any object towards earth, then this object will move 9.81 meter per second square acceleration. So that is meaning of that. So every object, if you drop, it will accelerate at 9.81 meter per second square. And you know that different planet have different masses and different radius. So that's why different planets have different acceleration due to gravity. So this is concept of Newton's law of gravitation. See, gravity is happen gravity is the force of attraction between two masses, and see, earth mass is very big, and radius is also very big. That's why like force of attraction between you and earth is that much high, you feel it. And if you throw any object towards earth, so it will accelerate through 9.81 meter per second square speed. So remember this formula: a force of gravity is equal to g, gravitational constant, multiplied by mass between m1 m2, that multiplication of masses of that both object, between that force of gravity is happening, and upon central distance between that object and square of that central distance. So see that force of gravity is g m1 m2 upon r square. So if my m1 object and if my m2 object, so if these objects are too near to each other, then force of gravity will increase, and if this object will far away from each other, then force of gravity will decrease. And if these masses are high, object masses are high, then force of gravity will increase. If these masses of object are low, see here low, then force of gravity will decrease. So I think you understand it, and thank you very much for attending this class. We will further see a lot of concept in engineering mechanics subject. So thank you very much.